So Android Studio is started, and we will now start a new Android Studio project. So let's call this project my new tutorial application, and let's click on next. Okay, this is for a compatibility version, so I don't change, it's okay, it will run on most Android versions. And this project will be made with an empty activity. That's fine, because we don't need any UI so far. We are just trying to get the position of the user. So okay, not changing that main activity. Let's click on finish, and let's wait Android Studio to prepare the project. Okay, that's done. So now the first thing, in fact, we need to wait a bit, that Gradle file are being built, so the project is being built, and the first thing, in fact, we will do with this project is to import our SDK into the project. So to do that, I'm just adding this line, so it's globally what is just set before. It's implementation. Okay, that's on first start. We have some short errors. Implementation, and I will get our SDK daily omni access. So this path is described in the documentation, of course. SDK.5.4. And that's it. And I resynchronize here the Gradle file, so that now we will download our SDK into the project. Okay, so now that the Stellar LBS SDK has been imported into the project, we can start modifying the application. And the first thing to do is to create an Android service that will allow background operations to work. So let's call this new Java class Android service, and that's it. On package, I will set it in a specific package, like example my new tutorial application .services, for instance. It will create a folder with the Android service inside. So because it's an Android service, this class will need to extend a service coming from the SDK, okay, which is now service manager. Okay, here the import has been done automatically. So now this service will allow background operations to be run. So what we need to do is to modify also the Android manifest file to declare, in fact, this service into the application. Okay, we do it this way, creating a service. Android name of the service, in fact, it's the name of the path we just created. So Android Studio find it himself. That's good. And now we are ready to go. We can rebuild the application, or we'll do it later. Now what we need to do, also in the service section, we will create a location service or location client, and that's the class that will be used in fact to match the SDK to get all location information. Okay, so we create a new Java class called location client. It's okay to be in the package of services. Okay, so we have this this class here, and this class will extend all that information you can retrieve from our documentation in the quick startup guide. Okay, so it extends this service handle, and it will also implement free class. So the first one is now SyncListener. So this class will provide some events when the synchronization with the cloud server will be done. And synchronization purpose is to get the positioning database that has been made during the calibration phase. So that's a positioning database that is used locally on the mobile to improve the accuracy of the positioning. And so that's number one, now SyncListener. Then we have, of course, now LocationListener. So that class typically will deliver on location change callbacks. So you will get every second the position of the user on the site based on trilateration of beacon signals. And typically we also add the sensors listeners that will tell you, for instance, if there is a need to activate the Bluetooth, which is mandatory for this solution to work. So I mean, if Bluetooth is not activated, you will receive an event indicating that you have to display in the application a message for the user to ask for Bluetooth activation. Okay, so that's it. Now here there's a nice feature. I do Alt and Enter, and all methods that are used by these three classes will be automatically added to the code. So of course there is no source code inside, but at least you have the declaration. So you see typically here the callback on location change when we will get the location, the status of the location, so if there is a mistake, errors and so on, you will get information from here, but most of the time you will hopefully get that status is okay. You will get an event when entering a site, that's first beacon detection, or leaving the site, and here you see some sensors callbacks, so to ask for BLE, so that's Bluetooth, to ask for location services to be activated on the phone. And the two last methods are about synchronization. So synchronization success will be received when the positioning database will be retrieved from the cloud, or if the positioning database is embedded in the application. That's also a possibility we have. You will automatically get the synchronization success message. So let's now build a constructor for this class. So public location client, and this constructor will require two parameters. One is the main activity that we will set. So the main activity is our main activity of the application, and the other one is the API key that needs to be used. And this API key you can retrieve from OmniAccess Stellar LBS platform. So when you will be manager of the site, or the manager of the site will be able to give you the API key. So it's a site that has been configured with the beacons and so on, some geofence that can be catched also by the application. So even when the mobile is entering a specific area, and we have a developer section, and in this section you can get your API key. So that's this API key I'm talking about. The first thing we need to do in the location client is to create a handle, which is a new now location handle, and this class is using activity parameter. The second parameter is the Android service class we just built previously, so that's this class. Okay, And the second one is the API key. Then we need two listeners, so one to receive a location event and one to receive a sensors event. So the first one is this, because that this class which is implementing the location listener. So I set this, and I also set this for the sensors listener, because that's the same class that is dealing with all that stuff that will be implemented in this methods. So I need, of course, to declare the now location handle. Name will be handle, and I will better do it like this. Okay, so that's first thing to do. Second step is to check that the handle is okay, of course, and then to ask, so that's underscore handle, and then to ask for a data synchronization in order to get back information from the cloud, so to get the positioning database and also the JSON file that is describing the geofence, so that the device will be able in standalone mode with this information to be able to send some event about geofence when the user goes in or out, and also to update the position every 1 second. So I call synchronize data, and the listener that is used is this one. Then we will go back to the end of the file while there is a synchronization success callback. So I will just set a log here to say, okay, that's location client, and saying synchro success. Okay, I will set up a breakpoint here in case of failure, but I will not write some code, but you can also, of course, do some logging and alerting, providing information about why the issue occurs. And what I will do after synchronize data, in fact, still testing the handle is okay, and I will just ask to start the location service like this. Start. And that's it. As soon as you do that, you will be able to receive some information into the on location change callback. First, the location status change will be called, so I can set up a log here to see that we will receive a status location what's the name of this? Oops. Okay, and after that I will set up a breakpoint also, and here log debug, we will see location client positions equals, and we can get from the location parameter that is sent here, we can get the longitude. Oh, that's GPS like coordinates. So this allows us to deliver seamless indoor and outdoor transition, because it's based on Earth coordinates. So we set latitude, and let's say we will get the latitude also. We get also the altitude. Of course, we got all this type of information. Just for debugging purpose, I'm just setting this one. So now we are almost ready to go. We just need to call to instantiate the location client. So we will do that from the main activity. So that's the UI of the application, which is an TUI, but we will call the location client class, location client, new location client, and you know, two parameters, the activity and the API key. So API key, I will just copy paste the one is here, and just we will use that, remove \n, and now we are almost ready to go. So now let's push the binary onto the phone. Okay, I do that. My phone is connected to my PC, and I will just set up a breaking point here. So here we are calling the constructor of the class from the activity, and we create a location handle, and we will call the synchronized data method of this handle. So let's go beyond, and we are receiving the synchronization success because the API key is okay. We get the synchronization success event, and in that case we are calling the start method of the location handle, and the location services will just start to run, and we are supposed to receive some events. So the first one is about the location status that has been changed and that is now available, as we can see here, and then we will receive some location updates as I'm moving on the site as a user. So we receive some location updates, and I will show you. So it's roughly every second I receive some location updates. And you see in this update the value of latitude and longitude, which are here. Okay, latitude and longitude, you can see the display here, and as I'm moving with the phone, you will see that there's light modifications, very slight modification on the latitude and longitude. And in fact, that's typically the position of a user who is moving on a site. And with this position, what we now have to do is to report the position on the map, on the indoor map, using mapping SDK for that. So that will be part of another tutorial, and I will show you how to do that with some mapping partners we have. The other thing I want to show you is what occur on the phone so far. There's nothing really important happening because we have no user interface. The activity is empty, so it's a basic hello world activity. We are just retrieving some positions into the application, and now we need to do something with that. Before moving to display the indoor map, I will explain how to do the same with geofencing. So it will be the ability to receive some events when the mobile will enter or leave zones that have been defined in the OmniAccess Stellar LBS Cloud Manager.